Let's begin with our left Riemann sum, which is also known as the left rule. As shown earlier in this method, the left part of our rectangle will go up until it hits the curve, then straight over and down. I will write out the general formula for our left Riemann sums here with the meaning of each of these variables. Because we are using the left Riemann sum, the left base point will be evaluated, and that will be our height. Then we can multiply that by our base, which is again our change in x. Then the total area would be the summation of all of our rectangles together. As you can imagine, with smaller and smaller changes in x, or said another way, with a limit approaching infinite rectangles, we get the analytical definite integral, or said another way, the exact answer with no error. I will now write out the equation for left Riemann sums if we have unequal step sizes here. Meaning if our rectangles are differing in size, we will use this equation. If all of our rectangles are taken to be the same width, then we can condense the formula by factoring out our delta x term, since all of these terms share that value. Usually this is written like so, where delta x is simply our upper limit of integration, commonly called b. A is our lower limit of integration, and n is our number of segments. One thing to note about the left Riemann sums is that they underestimate when we have an increasing region of our function, and then they overestimate when we have a decreasing region of our function. If you enjoyed, please like, subscribe, and consider checking out our YouTube memberships by clicking that join button down below. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I'll do my best to address your concerns.